Good morning, students.
Good.
Right. So first of all, sorry for the link issue. I thought that the first link which we have used was a recurring one, but it's not a recurring one. So therefore, few minutes before the lecture, just I noticed it's not a recurring one, so I created a link and shared with you. So I waited 10 minutes because of the delay of opening the link. ඒක open කරන්න වෙච්ච නිසා තමයි මම 10 minutes හිටියේ lecture පටන් ගන්න. Right. Anyway, so I think last week we didn't do the lecture because last week is a holiday. So before the last week, we commenced the lectures, vectors and matrices. And I told you that although the topic mentioned vectors and matrices, so topic indicates as vectors come first and then matrices. But actually, first we are doing matrices and then come to the vectors. Because some of the things that we are learning in the matrices is required to learn the vector concepts, right? So we have already gone through the basics, right? And I have uploaded the lecture note of basics to the LMS. I'm sure that you have gone through it, and also most of the things which we are learning here, most of means some of the things actually you have covered under the basic mathematics. So here today we are going to start the determinants. Right, determinants also I'm sure you have done determinants, especially under the, as far as I know, under the basic mathematics course, mostly you are concerning about finding the determinant of 2 by 2 matrices. Other than that, so you have done the 3 by 3 matrices as well. But anyway, here we are going to learn the determinants from the beginning, right? So from the beginning, how to find a determinant and all that, I will describe you from the beginning without consider about what you have done under the basic maths. Basic maths කරන පුදේ අමතක කරලා මුලින් ඉඳලම තමයි determinants යන්නේ, right? Okay. So here, what is it, right? First of all, so we need to clear on actually what do you mean by a determinant, right? What do you mean by the determinant? The determinant of a matrix is a special number that can be calculated from a square matrix. So first of all, in order to calculate a determinant, right? So whatever the given matrix to you should be a square matrix. It is a must, right? So most of the MCQ questions I have seen in the internet, as well as there are reference books, right? Very complex matrices have been given in the MCQs and ask you to find the determinant. But actually, if you look at the order or the dimension, if you check the dimension of the matrices, it's not a square matrix. So what the students are doing, they are not going to check the order, right? Rather than checking the order, they straight away go for the calculations. But halfway through the calculation, they are understanding that so this is not a square matrix, and so you can't find the determinant, right? MCQ වල දෙනවා ලොකු matrices. සමහර වෙලාවට 5 by 4, right? 3 by 4 matrices දීලා ඔයගොල්ලන්ට කියනවා determinant එක හොයන්න කියලා, right? So the answer is determinant is not cannot be calculated. So there are 4 answers. 3 answers are there. 3 numerical answers are there. Except that there's one answer, none of the above, right? Yeah, so students, what they are doing, ඒගොල්ලෝ මොකද කරන්නේ? Order එක check කරන්නේ. ඒගොල්ලෝ determinant එක calculate කරනවා, right? They are going to calculate the determinant. Halfway through on the මැදදී තමයි මතක් වෙන්නේ මේක square matrix එකක් නෙමෙයි කියලා, right? So therefore, the very first thing, especially in the MCQs, right? So if you are asked to find the determinant of a given matrix, first thing is you have to check whether it's a square matrix or not. Right? So then, so here is a 2 by 2 matrix, 3, 8, 4, 6, right? 2 by 2 matrix, 2 rows, 2 columns. right? So the determinant help us to find the inverse of a matrix, tells us things about the matrix that is useful in systems of linear equations, calculus, and more. So actually, so this finding of determinant, right? Finding of determinant is very useful, not only for this course, but later for most of the courses, right? So you know that since you have found the inverse of a matrix. In order to find the inverse of a matrix, you need to divide the cofactor matrix, right? You need to divide the cofactor matrix from the determinant. Either inverse corner, determinant corner, right? So since you have done the Cramer's rule, in order to solve the set of simultaneous equations, right, you can follow the Cramer's rule. So for the Cramer's rule also, you need to find, so if it is a 3 by 3, if it is a three sets of simultaneous equations are there, so you need to find 4 determinants, right? So other than that, right, so for some of the calculus related calculations, and also later on you are coming, when you are come to the third year, you will be having the last maths course called applied numerical methods. There you will be immensely use determinants, right? So therefore this concept of determinant is not uh, only limited to this lecture. It's a universal or lifelong life. Throughout the life you need to remember this, finding the determinant concept. It's important, right? So the symbol, right? So you know that for in order to represent the transpose, in order to represent the inverse, right? In order to represent the conjugate matrix, the inverse matrix, the transpose of matrix, we have learned different symbols. If there's a matrix called A, how to represent the A inverse? What is the symbol for A inverse? What is the symbol for A transpose? Right? So likewise, there's a separate symbol to indicate this is the determinant, right? This is the determinant. So usually the symbol for the determinant is two vertical lines either side, right? As an example, so if this is the matrix, A is equal 3, 8, 4, 6, 2 by 2 matrix. So determinant, right? Determinant, it symbolizes as this. You know this, but again, I'm reminding this, right? So sometimes in some of the references and also in the internet sources, questions that you can find from the internet, they from the words as the sentence they are not mentioning, find the determinant. Rather than that, they just use the symbol. Then you should know the symbol symbolizes determinant. That means they want you to find the determinant, right? So therefore, knowing the symbol is important. So if I ask you, what is the determinant of A? Since you have been mastered in determinants, especially I know that you have done finding 2 by 2 determinants. Tell me the answer for this one. Who has said it is minus 14? Minus 14, right? So any other different answers? So how you're going to calculate this one? So here, right? So I'm writing 6 multiplied by 3 minus 4, 4 multiplied by 8. Right. This is how to calculate. Right. So here the important thing is, right, so the direction, right? Sometimes, right, sometimes so sometimes some students, not all, right, they are changing the direction. For example, so initially you have to do this way. Right? Initially you have to calculate this one, then only this one. Sometimes some students exchange this. That means for them, what they are doing is 32 minus 18, right? 32 minus 18 equals plus 40. So this happens when you change the direction. So therefore, it is important to consider the correct direction. So first, you should go to this way and then this way. Right. And the other thing is, so right before you learn about the determinant, right? Before you learn about the determinant, so whenever, so if you are given any number, right? If you are given any number like this, so let's say it's 2, right? When you put like this, what it symbolizes? It symbolizes the absolute value of 2 or modulus of 2, right? So for any particular variable or a simple linear term, we can just put like this, right? In some calculations, you may have found this, right? So that is, here we are considering about finding absolute value. So the symbol is exactly like this. For the determinant also, we are using the exact symbol, but the meaning is different, right? ඔයගොල්ලෝ මාපාංක අපි සිංහල අපි කියනවා මාපාංකයෙන් හොයනකොට අපි දාන symbol එක මේ වගේ, right? Vertical lines එකක්. So before whatever the entity that we are considering. So here we are considering about mapang. So positive value we consider කරන්නේ. But same symbol we are using in the determinant, same symbol භාවිතා කරන්නේ, but it's a different concept. Right? So therefore you should be identify the correct context, because so if this is a matrix and if you have a symbol like this, definitely it is considered. So here you are asking about the determinant. So so there may be another situation with same symbol, right, with same symbol and variable inside, right? They may be asking about the absolute value. So beware of them. So according to the situation, it's not, so this symbol always not symbolizes the determinant and does not always symbolize the absolute value. මේ symbol එක හැම වෙලාවෙම determinant එකක් නෙමෙයි, absolute value එකක් නෙමෙයි. So therefore, according to the context, you need to identify what is the correct thing. Right, calculating the determinant. Right. First of all, the matrix must be square. Right. First of all, the matrix must be square. Right. For a 2 by 2 matrix, AD minus BC. Right. So what we have just talked. Right. So for the first of all, for the square matrix for 2 by 2, AD. So first you have to go for this direction minus BC. The determinant of A equals time A times D minus B times C. So that's how we are pronouncing it, right? That is how we are telling it. directions. Right. What is a singular matrix? Right? What is a singular matrix? So, what do you mean by a singular matrix? So, the term singular is connected with the determinant. So, then what do you mean by a singular matrix? Anyone? What do you mean by a singular matrix? If you have learned determinant, you should know this, right? What do you mean by the singularity of the matrix? Anyone? Yeah, the determinant is zero, right? So for the singular matrix, if there's a matrix and if someone say it's a singular matrix, so definitely the determinant is zero. So or else, so you can find, so whenever you are given a square matrix, then you can find the determinant, and if the determinant after the calculation, if the determinant becomes zero, so then we call it as a singular matrix, right? So here for this particular matrix, determinant is zero. So then it is called as a singular matrix. So if a matrix is a singular, right? If a matrix is a singular, how it will affect to the other calculation? For example, excuse me. Right? How the singularity of a matrix will affect to the other calculation. So if I'm asked, if a matrix is singular, if a given matrix is singular, what will happen to the inverse of a matrix? Inverse is also zero. Another answer? One answer I got, inverse is also zero. Another answer? If a matrix is zero, if a matrix, the determinant of a matrix is zero, what will happen to the inverse? Inverse is infinity. Inverse is? Infinity. I didn't get. You have to speak louder. It's infinity. Infinity. Infinity or not defined. So that means we can't find an inverse. So why? Because actually inverse is not going to zero. So here how you are going to find the inverse? Inverse is cofactor matrix divided by determinant. Cofactor matrix divided by determinant. So if the determinant is zero, so that means, right? That means determinant is zero. Hare binduai. Right? Determinant is zero means hare binduai. So then cofactor matrix divided by zero. So that means it's go to infinity, or we usually say, so inverse cannot find an inverse. So inverse is not defined. Right? So that is why, so it is important to know the singularity of a matrix. Right? So if someone said matrix is singular, so one thing happen is we can't find an inverse. For a 3 by 3 matrix, so let's say this is a 3 by 3 matrix. So then how we are going to find the determinant, right? How we are going to find the determinant. This is how. Right? How? So actually here, so one thing I should say, so here you can see here the determinant of the matrix. According to this slide, the determinant of the matrix is calculated based on the first row. Right? Based on the first row. First row එක base කරගෙන තමයි මෙතන මේ determinant එක හොයලා තියෙන්නේ. And I should say you can find the determinant of a given matrix based on any row or based on any column. ඕනම column එකක් ඕනම row එකක් base කරගෙන ඕගොල්ලන්ට matrix එක determinant එක හොයන්න පුළුවන්. So whenever you use the first row, second row, third row, or first column, second column, third column, the answer you should get is same. එකම උත්තරේ තමයි ලැබෙන්න ඕනේ මේ මොන විදියට හැදුවා. Like usually we are adapted, we are accustomed to use the first row in order to calculate the determinant. අපි සාමාන්‍ය පුරුදු වෙලා ඉන්නේ first row එක base කරගෙන determinant එක හොයන්න. But students, I am saying, right, so whenever you get a matrix, sometimes there can be any row or a column where you can easily find the determinant. For example, හිතන්න මෙන්න මේ matrix එකේ this is 0. This is 0. A, B, C, D, G, H, I. Right? So if you are going to calculate the determinant based on the second row, your calculations will be very much easy. I made a binduai. Demani row එක base කරගෙන determinant එක හොයනවා නම් calculations ගොඩක් අඩුයි. Right? Therefore, I'm always requesting you, whenever you get a matrix and ask you to find the determinant, scan the matrix first. From your eyes, scan the matrix first and identify what would be the easier row or a column you can select in order to find the determinant. Right? Okay. So this is how it happens. So since they have used the first row, right? They have used the first row. This is how it happens. The first element, right? So you get the first element. So you select the first elements mean first element එක select කරගෙනකොට so when we cut through the column and through the row, right? When you cut through the column and the row, this is what you left. මේකට විතරයි ඉතිරි. Right? So then a times you need to get the determinant of this one. Right? You need to get the determinant of this one. E times I minus H times F. E times I minus H times F. Right. So next. So you get the B, next element. So when you cut through the B and row wise cut and column wise cut, so you were left with this part and this part. So DG, so here DG, D and G, F and I. So B times, you need to get the determinant of this 2 by 2 matrix. Right? Finally, right, you get the last element C. So when you cut through the column and cut through the row, so what is left is this 2 by 2 matrix. DEGH. So then C times the determinant of this particular 2 by 2 matrix. So the next important thing is, okay, so how to determine this sign? Because so this sign here in between first two terms minus, next two terms plus. So this is not for almost all the rows and columns. So assume that if you are going to calculate the determinant with respect to the second row, so this is not minus, this is not plus. හැම වෙලාවෙම මෙතන minus මෙතන plus වෙන්නේ. Based on the row or a column that you are selecting to find the determinant, definitely, so these signs will change. Right? So I think you have learned it. So first, actually, there's something called minor. Right? So out of the minor, we are calculating the cofactor. Right? Then from the cofactor, we are calculating the adjoint. Sorry, now I can remember. So in order to find the inverse, you need to, not the cofactor, the determinant, but adjoint matrix divided by the determinant. Because first you are finding inverse එක හොයන්නේ cofactor එක determinant එකෙන් බෙදලා නෙමෙයි adjoint එක determinant එකෙන්. එතකොට first you are finding the minor, right? So all these minor matrix, so all these minus and pluses are coming as a result of cofactor. Then after transposing the cofactor only, you get the adjoint, right? So within the lecture series, we are going to find how to calculate the determinant, but inverse. But prior to that, I remind you. Anyway, here again, I'm saying, so although when we are finding determinant with respect to the first row එක හොයද්දී, so this is plus, this is minus, and this is plus. But when you're finding with respect to the second row, this is not the case. These pluses and minuses are changing, right? How come? So we'll describe later. So up to now, what you have to remember is how, so whatever, whenever you select a row or a column, so how you are dealing with each of three elements and with this 2 by 2 matrix. So how you find this 2 by 2 matrix along with the relevant element. මෙතන අවශ්‍යතාවය වෙන්නේ ඔයගොල්ලෝ අඳුර ගැනීම. අපි තෝරගන්න row එක හරි column එකත් එක්ක ඒ element එකත් එක්ක ඒ 2 by 2 matrix එක තෝරගන්න විදිය. Right. Example. So if I ask you to calculate the determinant with respect to the first row, right? So if you are calculating the determinant with respect to the first row, so the same sign. So the first term is plus, second minus, next one is plus, right? You can go accordance to that method. So with respect to the first row, please tell me what is the value of the determinant here. Right. So I found, I think, 3 answers. More than that. Saying all are saying minus 306. So this is the answer. Right. This is the answer. Right. So with respect to the first row, right, 6 times determinant of this 2 by 2 matrix, right? So that is minus 2 times 7 minus 8 times 5, right? So then 1 times, so this 2, right? So next one, with respect to this one, 4 minus 2 to 8. So the determinant of this 2 by 2 matrix. So intermediately, so the signs are, first one is plus, minus, and plus. So the answer is minus 306. Right. Now we are coming to the minor cofactor, right? The minor and cofactor. So the minor of the element is defined as a determinant obtained by deleting the row and column containing the element. Right? Minor of the element is defined as the determinant obtained by deleting row or column containing the element. Thus, the minors A1, B1, C1 are respectively. So, what do you mean by minor? Right? Minor ka kiyala kiyane mokadda? So, just what we have done up to now. Right? If we are considering finding the determinant with respect to the first column, first row එකයි හරහා නම් අපි determinant එක හොයන්නේ. So, what is the minor of A1? A1 के मायने का वेन्ने. So what they are telling is right. So actually, what do you mean by a minor? Minor is whenever you find the element, you select an element of the considered row or a column, right? So what they are telling obtained by deleting row or a column. So we delete the column, we delete the row, right? So the rest is this one, 2 by 2 matrix. So this one will be the minor of A1. So A1 के minor का में 2 by 2 matrix है. B2, C2, B3, C3. So likewise, you will be able to create. So we have already created and identified the minors of the rest of the elements. So by deleting the respective row and the column, right? So if it is B1, right? So we delete through the row, we delete through the row, and we delete through the column. So the minor is A2, A3, and C2, C3. So the 2 by 2 matrix consists of A2, A3, and C2, C3. Likewise, C1 also we can construct. So that is what we call as minor. So minor we already know. So here is how. Here is an example where they are going to find the determinant with respect to the first row. So they have step by step shown us what is the minor of each and every element and how to find the determinant of that minor. Right? For A11 means the first element, first column element. So it is 2, right? 2. So then when we cut through the row and when we cut through the column, so the rest of the 2 by 2 matrix is 0, 4, and 5 minus 7. So the determinant is minus 2. So then A12 means the second element, which is 3. So when we cut through the column and cut through the row, So the rest of the elements are left is 6, 1 and 4 minus 7. So then when you find the determinant, so this is minus 46. Likewise, A13 is the last element of the first row, that is 5. When you cut through the row and the column, so the rest of the 2 by 2 matrix is 6, 0, 6, 0 and 1, 5. So when you find the determinant, that is 30. Right. So likewise, not only with respect to the first row, they have found almost all the minors of all the elements, right? So as I have told you, so we will be able to find the determinant with respect to first row, first column, first row, second row, third row, or first column, second column, third row column. මේ ඕනම row එකක් කරේ column එකක් කරේ base කරගෙන ඔයගොල්ලෝ determinant එක හොයන්න පුළුවන්. එතකොට so therefore every element of this matrix has a minor. ඕනම තැනක ඕනම element එකක් ගත්තොත් එයා වෙනුවෙන් ඉන්න minor කෙනෙක් ඉන්නවා. So that is one. So here you can see with respect to each and every element, they have found the minors. Just to show you how to find the minor. Sometimes some students are thinking minors are only with respect to the elements for the first row. First row elements were with minors. No, it's not the case for almost all the elements of the matrix, of the given square matrix, there are minors, where you can find the determinant. So next one is the cofactor. So the concept of cofactor is the one which determines the sign. So that means, so here plus, minus, plus, plus, minus, plus, right? So that will be determined by, that will be judged by the concept of cofactor. Cofactor කියන concept එකෙන් තමයි ඒක judge වෙන්නේ. Right? So I told you, with respect to the first column, if you are selecting the first column, first term plus, next term minus, and then plus. But when you select the second row to determine the determinant, that is not the case. The pluses and minuses are interchanged. So how it comes? So this is, in order to judge the cofactor, so this is the way, minus 1 times R plus C. R plus C means minus 1 times row number plus column number. As a power, row number plus column number. Right, multiplied by minus. So that is altogether is called as cofactor. Right, minus ඍණ එකේ power එකෙන් වැඩි වෙන power එකට යන්නේ row plus column. Right, so if you look at, so here if you go, so here we have found the determinant with respect to the first row. Right, first row. So then when we come to the first column means first column number is first, row number is 1. Right, column number, both column number and row number 1. So I'm going to find the determinant with respect to the first row. So then when I get the first element A, right, when I get the first element A, so the row number is 1. The column number is 1. So this is altogether 2. Right, then you need to get the minus 1 to the power 2. So here the answer is 2. So we put the answer as a power of minus 1. So minus 1 to the power 2. What is the answer? What is the answer? Minus 1 to the power of 2? Plus 1. Plus 1. Right? Plus 1. Right? Plus 1. So therefore, here you can see it is plus. Metan n plus. Right? Right. So next we will select the second element of the first row, B. So if you consider about the B, the second element, what is the row number? What is the row number? Student, what is the row number of the element B? Plus 1. 1. 1. Right? Right. What is the column number? 2. 2. So then what is the summation? 3. So then what we are doing, we get the minus 1 to the power 3. What is the answer?
-1.
Minus 1. So that is why here in front of the element B, here it is minus. Right. Next, C, the last element C. What is the row number?
1.
1. Column number?
3.
3. Then what is the answer? 1 plus 3, 4. So then we put it as a power of minus 1. Minus 1 to the power 4. What is the answer?
+1.
Plus 1. So that is why here plus. Right. So whenever you check for the next column, sorry, next row, let's assume now we are going to find the determinant with respect to second row. ඔයාලගෙන් කෙනෙක් then second row එක පාවිච්චි කරලා determinant එක හොයන්න යනවා. As I told you, although you found the determinant with respect to the first row or a second row, the answer should be same. එකම උත්තරේ එන්න ඕනේ. නමුත් දැන් අපි බලමු second row එකට. So now we are going to find the cofactors of second row. So the first element is D. What is the row number?
2.
Huh?
2.
2. Column number?
1.
1. So then answer is 3. So if you make it as a power, what is the answer? Minus 1. So therefore, for the first element D, when this becomes D, අපි second row එක ආශ්‍රයෙන් determinant එක හොයන්නේ D times. So මෙතන මේක වෙනස් වෙනවා. So this 2 by 2 matrix changes. Anyway, for this first term එකට මෙතන ඉස්සරහට minus එක. Right. Whenever you calculate for E, second එකට හෙව්වම ඔයගොල්ලෝ දකිවි. So this will become plus, at the plus වෙනවා. And if you calculate for the F, you will observe this will become minus. Right. So that's why I told you with respect to each and every row and a column, so this will change. Make a change, right? With respect to each and every column, row and a column, this will change. Right. So therefore, whenever you select another row or a column other than first row, because now you are adjusted and you are accustomed to find determinants with respect to the first column, first row. ඔගොල්ලෝ දැන් පුරුදු වෙලා ඉන්නේ first row එකට සාපේක්ෂව determinant එක හොයන්න. ඒතර ඔගොල්ලෝ දන්න අනිවාර්යයෙන්ම plus minus plus. ඔබ තමයි ලකුණ වෙනස් වෙන්නේ. But whenever you go to find the determinant with respect to second row or any other row or a column, so this minus or pluses changes. So this is how you are going to calculate it. Minus 1 to the power row number plus column, row and the column number. So the answer you get is determine the sign before each and every element. Okay, so that thing, I think you already know this, but for more clarifications, I'm reminding you. So here they have shown you that almost all the calculations, cofactor calculations. Right. Right. So here they are 235. 235 is the first row. 235 is the first row. So here you can see 235. So they have tried to find the determinant with respect to the first row. So after this is the minus already. So they have found the minus, but here they are showing us how to find the cofactor. So since this is the first row, so first row first element 2 minus 1 to the power 1 plus 1, right? 1 plus 1, so it is plus. So then the second element of the first row is 3 minus 1 to the power row number 1, column number 3. So it is minus 1 to the power 3. So therefore it is minus. So then final element of the first row, 5. So minus 1, row number 1, column number 3. So altogether 4 minus 1 to the power 4 means plus. So this is how pluses and minuses are. Right. So here, expand the determinant, right? Whenever, so you have been given a 3 by 3 matrix, right? You have been given a 3 by 3 matrix. So there, so with respect to when you are going to find the determinant with respect to the first row, 6 times cofactor of 6. So within the cofactor of 6, definitely you need to find the minor. The cofactor of 6 is minus 1 to the power of So next, so here you will see 6 times cofactor of 6 plus 2 times cofactor of 2 plus 3 times cofactor of 3. Then you may be wondering, hey, with the plus, right? But here actually they are using plus, but when you calculate it inside, you make cofactor calculate inside, so this will automatically become minus. So here you will see it will become minus, right? So therefore, so the method which we have followed is 6 times cofactor of 6 means minus 1 to the power 2 multiplied by minor of 6. Then plus 2 times minus 1 to the power 3 multiplied by minor of 2. Plus 3 times minus 1 to the power 4 multiplied by minor of 3. Right now, you will be able to calculate determinant with respect to any column, any row. දැන් ඔයගොල්ලන්ට පුළුවන් වෙන්න ඕන column එකක්, ඕන row එකක් ආශ්‍රයෙන් determinant එක හොයන්න. Right. So here you can see evaluate the determinant. Right. Evaluate the determinant. Evaluate the determinant with help of second row. Right. With help of second row. With help of third column. So now they have shown you what is the value or what is the determinant when you evaluate it with respect to the second row. Second row එක evaluate කරාම determinant එක හොයලා තියෙනවා. So please try to find what is the determinant when you find the determinant with help of third column. So that means here with respect to this column, try to find the determinant. Determinant එක හොයන්න third column elements use කරගෙන. Try to find the determinant and tell me what is the answer you got. So here you will see with respect to the second row how they have evaluated. So with respect to the second row means this one. Right. So it is already done. Now you are asked to find the determinant with respect to the third column. So here students, I'm requesting you to actually work on this, right? So you know that, so definitely you should get the answer 23 whenever you evaluate the determinant with respect to third column. ඔගොල්ලෝ third column එකට respectively evaluate කරත් ඔයාලට එන්න ඕනේ 23ම තමයි. But I am requesting you to check by yourself, right? Check by yourself whether you get the same answer. So I hope all of you have checked that you will get the same answer, although you use the second row or third column to find the determinant. You should get the same answer. So this is the answer when you calculate the determinant with respect to the final row or as the final column, third column. 4 times cofactor of 4, cofactor of -1, cofactor of 2. 23 again. Right. So next comes the properties of determinants. So this is actually very important. Learn about the properties of determinant, right? So here, so the first property. So there are, I think, altogether 5 or 4 properties are there. So learning this or remembering these properties will help you to easily find out the answers for especially for the MCQs, right? Properties of determinants. The value of determinant remains unaltered if the rows are interchanged into columns or columns are interchanged into rows. So actually, if I'm asking, what do you mean by rows are interchanged to columns and columns are interchanged to rows? What is that? Any other way that you can describe it?
Transpose.
So when we interchange columns to rows and rows to column, we call it as a transpose, right? So what they are telling is, so the determinant of a matrix and its transpose are same, right? මෙතනදී කියන්නේ determinant එක. දීලා තියෙන matrix එක. Determinant of a given matrix is same as the determinant of its transpose, right? Determinant දීලා තියෙන matrix එකේ determinant එකත් ඒකෙම transpose එක අරගෙන calculate කරන determinant එකත් දෙකම සමානයි. Right? This is one MCQ point, right? So in the MCQs again, you will get a big matrix like 5 by 5 or 6 by 6 matrix. And within the question, they are saying, so the determinant of this particular matrix is this one. Now, right now, as the question, you will be asking, right, find the determinant of the transpose. Now, what the students are doing, if they do not know this property, they are going to calculate it. No need to calculate. You can directly say determinant of the matrix is going to be same as the determinant of the transpose. Right? So therefore, it is important and by yourself. Right? You can have a simple example, 3 by 3 example or 2 by 2 examples even. Right? By yourself, you can check whether this is true or not. Right? Make all of them are going to check matrix determinant and also you can convert it to transpose and then you can find the determinant of the transpose. Then you will tally out the answers that you have got for both original matrix and the transpose. Right. So the property number 1, here it is already proved. I'm not going to go through the proof, right? So if there's anyone who's interested, so I have put the proof here. Right. Right, by yourself you can calculate, right? So you can calculate so the determinant of the original matrix and the transpose, right? Right, okay. So tell me, expand the determinant of this matrix. Right, the first matrix A, 1, 2, 3, 4, 2, 5, 4, 3, 4, 2. So tell me, what is the determinant of A? So then you can you by yourself can check what is the determinant of the transpose as well. Right. So the property number 2, if two rows or two columns of a determinant are interchanged, the sign of the value of the determinant changes. What they are saying, the property number 2, if two row or two column of the determinant of a determinant are interchanged, the sign of the value of the determinant changes. Right. What they are saying is, so for example, if we consider about these two rows, these two columns, right? What I'm doing is I'm exchanging first column to second column. I'm exchanging these two columns. මම columns දෙක තියෙන තැන මාරු කරනවා. Second column එක first column එක තියෙන තැනට දානවා. First column එක second column එක තියෙන තැනට දානවා. So I'm exchanging two columns. Then after exchanging the columns, so before let's think. So originally, let's think. So the determinant of this matrix is C. Determinant is C. So after that, after finding the determinant, I'm doing the exchange. Right now, I'm exchanging two columns. Right now, I'm exchanging two columns, and then now again I'm calculating the determinant. Right, definitely. So the answer I get is minus C. Not C, but minus C. So this is valid for rows also. If we interchange two rows, so first row comes in place of second row, and second row comes in place of first row. Rows දෙක තියෙන තැන් දෙක මාරු කරා. I have changed the places of two rows. So then after doing the interchange, if I calculate the determinant, again my answer is minus C. Right? If two rows or two columns of a determinant are interchanged, the sign of the value of the determinant changes. So here you will see, so originally, right? Originally this should be there. Original matrix එක original determinant හොයන පාවිච්චි කරන matrix එක මේක. But what we have done, we have exchanged first row and the second row. First row එකයි second row එකයි මෙතන මාරු වෙලා. So definitely the determinant, in the determinant, the sign should be changed. Right? That is also by yourself you can check. ඔයගොල්ලන්ට check කරන්න පුළුවන්. Right? So here, so they have interchanged the two rows, row 1 and row 3. Row 1 and row 3 මාරු කරලා. So when you calculate the determinant and check the answer, definitely the minus comes out. Right, property number 3. Right, property number 3. If two rows of the determinant are identical, if two rows or columns of the determinant are identical, the value of the determinant is 0. Make a point MCQ වලට, right? So in the MCQs again, you will be given a 3x3 or a 4x4 matrix and ask you to find the determinant. But if you closely look at the matrix, you will identify either two rows or two columns are identical. Rows දෙකක් හරි columns දෙකක් හරි එකම වගේ. Same elements are there. So then definitely, without doing single calculation, you can write down the determinant is determinant එක බිඳුවයි. So this is the property number 3. If two rows of or columns of a determinant are identical, the value of the determinant is 0. So that the first two rows are identical. Here you can see the first two rows are identical. So then when you calculate the determinant, it will become 0. So here, right? So here you can see the first row and the third row. First row and the third row, they are identical. So then determinant is going to be 0. You do not need to do single calculation. Based on the property 3, you can say that like that. Property number 4, right? If an element of a row or a column, right? If the element of any row or a column of a determinant be each multiplied by a same number, the determinant is multiplied by that number, right? Originally, let's assume, right? Originally, let's assume there's a matrix. Maybe an original matrix. And we have found the determinant of this particular matrix. There we got the determinant as C. Determinant C. Right. So then after calculating the determinant, what we have done, we have multiplied the first row with a constant. But that constant should be same for almost all elements of the row. පළවෙනි row එකේ තියෙන ඔක්කොම elements එකම constant එකකින් වැඩි වෙනවා. For example, here as you can see, almost all the elements of the first row is multiplied by k constant. Right? Is multiplied by k constant. Right? So then the output, so the resultant answer, when you after multiplying almost all the elements of the first row with the constant k, you get the determinant. Determinant should be ordered. So originally our determinant is C. Our original matrix එකේ determinant එක C. Then මේක එන්න ඕනේ KC. Whenever a particular row or a column, එක row එකක් වෙන්නත් පුළුවන්, column එකක් වෙන්න පුළුවන්. It can be a row or a column when it is multiplied by a constant. Right? The determinant also will be multiplied by that same constant. So that is the property number 4. Right? So this point is important in 2 times. Whenever you given a matrix, right? Whenever you given a matrix, and there they have mentioned the determinant. And again, there's another matrix, right? If you closely observe, you will see, for example, here, assume that this is the original matrix you were given. මේක තමයි ඔයගොල්ලන්ට දීලා තියෙන original matrix එක. Assume that the determinant of this particular matrix is 92. I'm assuming, not the exact value. අපි හිතනවා මේකේ determinant එක 92යි. Right? Next, so you will be given this particular matrix in the same question. But if you closely look at the first row, you will identify that almost all the elements of the first row are multiplied by 6. Same constant. So then you can take 6 out. Whenever you get the 6 out, right, 6 out, you will get the original matrix with the determinant of 92. So then rather than finding the determinant again, what you can do is you can just multiply 92 by 6. Right? You can rather than again finding the determinant, or else you may be given originally you will be given this matrix to find the determinant. සමහර වෙලාවට මේ වගේ matrix එකක් දෙන්න පුළුවන් determinant එක හොයන්න. Right? So rather than going to straight away find the determinant, because here you will see with respect to the other 2 rows, second and the third row, the first row is bulky. big numbers are there, right? Whenever you face this sort of a situation, what you can do is closely observe the first row and try whether if you can get some fact out. සාධකයක් එළියට ගන්න පුළුවන්ද කියලා බලන්න දීලා තියෙන row එකේ. So then, if you can do that, so this particular matrix will be reduced to this matrix. So finding the determinant of this matrix will be easy rather than finding the determinant of this matrix. Remember that you will not get a calculator for almost all these calculations. That's why I'm telling you. Right? So therefore, reducing, if you can reduce this particular matrix to this, so then what you have to do is you just want to find the determinant of this matrix only. And then after finding the determinant of this matrix, you can just multiply it by the factor or as the constant that you have, keep it outside. Right? So therefore, right, so whenever you get a matrix, so because when you look at the matrix also, you will see some unusual placement of elements when you compare the first row with the other two rows. Other two rows are too simple and the first row seems to be bulky. At that situation, whenever you see these type of situation, you can check whether you can take a factor out. If it is possible, take that factor out and find the determinant of this simple matrix, and then you can multiply it with the. So here also this can be checked by yourself, right? You by yourself check whether this is true or false. Right. Property number 5, the last property, as I have mentioned. Right. The value of the determinant remains unaltered if two elements of one row or column to be added any constant multiple of corresponding element of any other row or column. What is this? This is somewhat tricky. So the value of determinant remains unaltered if the elements of one row or a column be added any constant multiple of corresponding elements of any other row or column respectively. So that is what. So what they're telling is, let's assume this is the original matrix and we have found the determinant of this matrix. Let's assume it is C. The matrix determinant is C, value C. Now what we are doing, so here you will see that then right? We select the second column and multiply it with a particular constant. And මෙතන multiply කරලා තියෙන L කියන constant එකේ. Whatever the constant it can be. So select the second row and multiply by L. And next select select the second column. Now select the final column or as the third column and multiply it by N. දෙවනි column එක L වලින් වැඩි කරලා තුන්වෙනි column එක M වලින් වැඩි කරලා. So multiply means you have to multiply almost all the elements of the column with respective constant. So here almost all the elements of the second column is multiplied by L. Right? Almost all the elements of the third column is multiplied by N. Right? Then what we have done is, so L times second column plus M times third column is added to the first column. It was a may වැඩි කරලා එන උත්තරේ first column එකට add කරලා. Right? L times first column plus L times second column plus M times third column is added to the first column. So now you can see this is the මේක තමයි සම්පූර්ණ first column එක දැන්. Now the first column is fully altered. Right? So although this has happened, the determinant is going to be again C. Determinant unaltered. So you may be wondering why, right? You may be wondering why actually. So determinant again why. So actually when you consider this altered matrix, alter करब matrix का दिया हुआ value है. Right. So this particular altered matrix can be divided into three matrices. Make a maybe this is our original matrix. This is our original matrix. Plus, so actually this matrix is divided into three. When you multiply L times this particular matrix, M times this particular matrix, and when you add all three matrices together, so it again forms this matrix. සරලව මේ matrix එක break down කරලා තියෙනවා. Right? So when you break down this altered matrix into three, you will notice that what is the determinant of this matrix? Why? The determinant of this matrix, you are saying 0, why?
Two columns are same.
Two columns are same. Right? Under the one property of determinants, we learned that if two rows or two columns are same in a particular matrix, the determinant is going to be equal to 0. Right? Now come to this matrix. What is the determinant of this matrix?
Again 0.
Again 0. Why? Two columns are equal. So therefore, although we have multiplied the second column with L and multiplied the third column with M and added to the first column. Second column में L वाली वाली करला, third column में M वाली वाली करला, अभी first column में add करला. මේ තරම් ලොකු first column එකක් හදාගත්තා. Determinant එක වෙනස් නොවුනේ. Why determinant does not change? That is because the determinant of this matrix and determinant of this matrix is 0. So therefore, the determinant, so altogether, the determinant of this particular matrix is again C. That is why determinant is unaltered. Make a determinant එක තමයි මෙතනට එන්නේ. So that is the property number 4, right? Again, I'm saying, by yourself, you by yourself can check this property, right? These are examples. You by yourself can check this property. So next, there's a property number 6 also. It's not a principal property, but there's a property like a very simple property. If all elements of a row or a column are 0, determinant is 0. This should be neither, right? When you, so normally you are accustomed to find the determinant with respect to first row. That method of first row determinant what will happen? 0. So whenever you get a matrix like this, right, assume that, okay, so here you will notice it suddenly because all zeros are in the first row. First row එකේ තිබ්බ නිසා දැක්කා. හිතන්න එහෙම නෙමෙයි. All the elements of the third row is 0 and here this is some values. There are some values for these things. 3 and 2. Then you may not recognize it. Because you are accustomed to get the determinant, find the determinant with respect to the first row. ඔගොල්ලෝ පුරුදු වෙලා ඉන්නේ first row එකේ determinant එක හොයන්න. දැන් මෙහෙම එකක් දැපු ගමන් ඒත් හොයනවා determinant. Right? Although you have noticed this sort of a situation, since you have been accustomed to get the determinant with respect to the first row, you are going to calculate again. No need to calculate. If a full row or a full column is totally zero, then the determinant is zero. No need to find it. Then again, there's an additional property, again, property number 7, right? So all these properties are very important for your MCQs. Remember that. If in determinant, all elements above or below, the diagonal is 0. So I'm asking, before going to the property, so can you give me a name to represent this particular matrix? මේ matrix එකට කියන්න පුළුවන් තනි නමක් දෙන්න.
Upper triangular matrix.
So this one?
Lower triangular.
Lower triangular matrix. So here what they are telling is, under the property number 7, if in a determinant, if it is all elements above or below is diagonal are 0. So that means in an upper triangular or a lower triangular matrix, right, you can easily calculate the determinant by multiplying the diagonal elements. Upper triangular hari lower triangular hari matrix එකක determinant එක හොයන්න ඕන නම් what you have to do is you just multiply the diagonal elements. Diagonal elements ටික වැඩි කරා නම් හරි. A multiplied by E multiplied by I. So this is also, you can check by yourself. You can create by your own an upper triangular matrix and find the determinant with the usual way. Usually with respect to the first row, you can find the determinant. Now you have the answer. With that answer, you can compare the answer. Again, you can find the determinant by multiplying the 3 elements along the diagonal. Then you will recognize both of the answers are equal. So no need to go for long method. For example, assume this is okay. This is easy because this is 3 by 3 matrix. But what if you are given 4 by 4 or a 5 by 5 upper triangular or lower triangular matrix and ask you to find the determinant? Then with the dimension of the matrix, if you are going to find the determinant with the usual way, it will take some time. So other than that, it is very easy. You can just multiply diagonal elements. Right. Special types of determinants. Right, I think you can remember symmetric matrix and skew symmetric matrix. Under the first lecture, we learned that. Right, we learned what do you mean by symmetric matrix and what do you mean by skew symmetric matrix. Right, if you look at this particular matrix, what is this? Is it a symmetric or skew symmetric? The first one.
Symmetric matrix.
Symmetric. So this is skew symmetric. So how to recognize? So along the diagonal, so here HH, GGFF. So in the skew symmetric, minus is coming out. Right. So special type of determinants. Now they are telling something about special type of determinants. Orthosymmetric determinant. If every element of leading diagonal is same, remember that in a symmetric matrix, samani symmetric matrix, almost all the elements are along the diagonal is not same, right? So what the property we are checking, symmetric matrix check kale. So whether this going to be equal to this, right? This going to be equal to this. And this going to be equal to this. Okay, tamaya symmetric matrix check kare. But other than that, what they are telling is, if every element of leading diagonal is same as the conjugate elements as same and the conjugate elements are equal, then the determinant is said to be orthosymmetric determinant. So what is the leading diagonal here? This is the leading diagonal. So if every element of the leading diagonal is same, samana. So throughout the diagonal, the element A is there. ඔක්කොම elements ටික සමානයි. And the conjugate elements are equal. So what are the conjugate elements? These are conjugate elements, right? So every element of the leading diagonal are same, and also the conjugate elements are equal. Then the determinant is said to be orthosymmetric. So this is an orthosymmetric determinant. So next one is Q-symmetric determinant. If the elements of the leading diagonal are all zero, then make your ඔක්කොම leading diagonals ටික zero. And every other element is equal to its conjugate with sign change. So මෙතනදී A, it's minus A. Sign change එකක් තියෙනවා. It's B minus B, C minus C. So if all the leading diagonal elements are zero and also every other element is equal to its conjugate with sign change, that determinant is called Q-symmetric determinant. This Q-symmetric matrix එක තමයි කියන්නේ determinant එකේ properties ගැන කියන්නේ. Right here also this is not the only the property of symmetric matrix but symmetric determinant. මොකද symmetric matrix කියවම මීට වඩා properties අඩුයි. Conjugate elements සමාන වීම තමයි අපි හිතන්නේ. මෙතන conjugate elements ඍණ ලකුණක් එක්ක සමාන. But here other than that they are saying if the leading diagonal is same, මෙතන leading diagonal element එක same වෙන්න ඕන for the orthosymmetric determinant. In the skew-symmetric determinant, all the elements of the leading diagonal should be zero. Then only it can be considered as Q-symmetric determinant. Right, prove that the odd order determinant of skew-symmetric matrix vanishes. Make a property, right? Under these two special determinants, මෙතන කියනවා prove that odd order determinant. So students, what is the determinant? Tell me, find the determinant of this matrix and tell me the answer.
Zero.
Any other answers? Any other answers? No answers. Should be 0. Right? Right. Why it's telling, prove that odd order determinant of skew symmetric matrix is vanishes. Remember that. So they are specifically saying here odd order. So what do you mean by odd order? What is the order of this matrix? 3 by 3, right? So 3 by 3. In order to find a determinant, so a matrix should be a square matrix. So therefore 3 by 3 is correct, right? So also there can be 4 by 4 matrix, right? So there can be 4 by 4 matrix as well, right? 3 by 3 and also 4 by 4 and also 5 by 5. So what do you mean by odd order? So tell me, 4 by 4, is it odd order or not? 4 by 4 is odd order or not? 4 by 4 කියන එක odd order ද නැද්ද? Yes or no?
No.
No. Right, students, what is odd order? Odd means what? Otte sankhya. So 3 is odd, 3 odd, 5 odd, 7 odd. So 3 by 3, 5 by 5, 7 by 7, 9 by 9. So those are odd order matrices. What are even order? 2 by 2, 4 by 4, 6 by 6. Right? So those are even order. So that is when විශේෂ දෙයක් නෙමෙයි odd order කියන්නේ whether it's odd එක odd ද නැද්ද. So since this is a square matrix, then because square matrix එකක් නොවුනා නම් 3 by 4 2 by 3 ඔහොම එන්න පුළුවන්. නමුත් since this is square matrix එකක් වීම නිසා number of rows and number of columns are equal. Right? Number of rows ගානම තමයි columns ගාන. So අපි odd order කියලා කියන්නේ odd order. Odd order means 3 by 3, 5 by 5, 7 by 7 කියන odd order matrix. Odd order square matrix. Right? අපි square කියන එක ආයෙ භාවිතා කරන්න ඕනේ නැහැ. You know 3 by 3, 4 by 4, 5 by 5 මේවා square තමයි. Out of them, 3 by 3, 5 by 5, 7 by 7, those are odd order matrices. So even order means 2 by 2, 4 by 4, 6 by 6. So here what they are saying is, prove that odd order determinant of skew symmetric matrix. It's a hammer skew symmetric matrix because there can be skew symmetric matrix with even order. Skew symmetric matrices even order. 4 by 4 skew symmetric matrix 6 by 6 skew symmetric matrix So those are even order. Odd order means 3 by 3, 5 by 5, 7 by 7. So those are odd order skew symmetric matrices. Only odd order skew symmetric matrix. So they are the determinant of odd order skew symmetric matrix 0. The determinant of odd order skew symmetric matrix is always equal to 0. This is also a good point for MCQ. Or a structured essay question, you may be given a matrix. Right? You are asked to find the determinant of the matrix. If you can remember this property, you can straight away say that this is an odd order skew symmetric matrix. Right? In order to be a skew symmetric matrix, determinant of skew symmetric matrix, almost all the diagonal elements should be 0 and the conjugate element should be equal with minus sign change. Right? So that property is here. That properties are there. So therefore, this is the special determinant of skew symmetry. The other specialty, this is odd order. Only odd order determinant of skew symmetric matrix always becomes 0. එතකොට මේ වගේ 5 by 5 එකේ determinant එක බිඳුවක්. 7 by 7 determinant බිඳුවක්. But this is not valid for the even order. Right. These are properties. It's good if you can remember these. Then it will save your time. Prove that the skew-symmetric metric determinant of even order is a perfect square. So now, student, tell me the determinant of this one. Oh, determinant is 4. Right. So what they are telling? Skew symmetric determinant of even order. Then අපි කලින් කතා කරේ odd order skew symmetric determinant. But now we are talking about the even order skew symmetric determinant. For even order skew symmetric determinant, the answer is a perfect square. Answer එක perfect square එකක්. හරිනේ. Right. For example, so here our answer is 4. 4 කියන්නේ perfect square of 2. දෙක වර්ග කරාම 2 to the power 2 is 4. Right? So for the even order skew symmetric determinants, the answer of the determinant is a perfect square. Perfect square එකක් තමයි අපිට answer එක විදියට ලැබෙන්නේ. For the even order skew symmetric determinants. This is also by yourself you can check. This is an example for that. Right. So that is the end of the lecture, determinant. Right. So I'm actually saying, so sure that you have learned determinant under the basic maths, but here I believe you have learned something more than that, something added to that. But here only we have covered only the first part of the determinant here. Second part of the determinant also waiting, right? So next week, so since now it's 15 minutes is only, so I'm not going to start a new lecture. So as the next lecture, we are going to commence the determinant part 2. So there you will learn about, based on the determinant, we will be able to solve a lot of equations. So we are check the homogeneity of the equations based on the determinant. Sorry. So we'll do the lecture next week, determinant part 2. So therefore, thank you for joining with this lecture. So now on, you can send me the messages for the attendance. We'll upload the lecture note to the LMS. Thank you.